Section 1.5, Intersections, Unions, and Compound Inequalities. Graph and write using interval notation. So we're supposed to graph 0 is less than x. I don't like that. I prefer to graph when x is on the left. So I'm going to flip this inequality. I'm going to put the x on the left, the 0 on the right. Notice that the arrow is pointing at the 0. When I flip it, I have to flip the inequality too. So the arrow is still pointing at the 3. So x is greater than 0. That makes more sense to me. X is greater than 0. Do not include the 0. Go to the right. X is less than 2. Do not include the 2. Go to the left. So we use our hollow circles to show that we are not including the endpoints. What is the intersection? And means intersection. Intersection is where both are true at the same time. They must both be true. Sometimes you'll see this symbol, meaning intersection. Where are both of these inequalities true at the same time? In between 0 and 2, not including the endpoints. We want to have interval notation, start at 0, end at 2, do not include the endpoints, so we use parentheses. Now we have x is less than -2, or we have x is greater than 4. This time we want or. That's a union. It could be just one is true, could be both are true. One or the other or both. Union is sometimes represented with just a U, a capital U. So where is one or the other or perhaps both true? Well, they're not going to be both true, but you can have one or the other on the endpoints. So that's our solution set. From negative infinity to -2 using open parentheses for negative infinity always, and for -2 because we don't include the endpoint. Or from +4 to positive infinity. And sometimes instead of or, you'll see a U there between those interval notations. So in the previous example, x is less than -2 or x is greater than 4, it cannot be abbreviated as 4 less than x less than -2. I'll tell you why. In general, for a is less than b, a is less than x and x is less than b can be abbreviated as a less than x less than b. Compound inequalities must have the following characteristics. It must always be less than. Both inequalities must be less than. And a must always be the smaller of the two numbers. Notice in our previous example, 4 is less than x is less than -2. 4 is larger than -2. So that is not a proper compound inequality. You must always have less than, or less than or equal to, less than or equal to. And the first number a must always be the smaller of the two numbers. Caution, a is greater than x and x is less than b cannot be abbreviated as a greater than x less than b because the inequalities, one's greater than, one's less than, they must both be less than. So let's solve these compound inequalities. We have an and, that means an intersection. Let's solve our first inequality. We have +1, so we will subtract 1 from both sides. -6 is less than 3x. Divide both sides by 3. -2 is less than x. And we're talking intersection. 3x plus 1 is less than or equal to 4. Let's solve it. Subtract 1 from both sides. 3x is less than or equal to 3. Divide both sides by 3, and x is less than or equal to 1. We want to graph both of these. We're looking for the intersection. X is less than -2. X is less than or equal to +1. So where are both of these true at the same time? This is an AND situation, an intersection. They must both be true at the same time. That happens for X less than -2. That's the only place on the number line where they are both true at the same time. And in interval notation, that gives us -∞ to -2, parentheses on both of those. Here's our next example. We have a compound inequality. We're solving for x. We want to get x, the x term by itself in the middle. We're going to subtract 1. Usually we say subtract 1 from both sides, but this compound inequality actually has 3 parts. So it's -6, 3x, 3. Now we want to get the x by itself. We divide all 3 parts by 3, -2, x, 1. So we have solved our compound inequality by isolating x. Our solution is not equal to -2, but it can be equal to 1. And we want all numbers in between. So that's our solution. Interval notation, parentheses for the -2, 1. How do we show that we include the 1? Square bracket. Our next example, it's an OR problem. It's a union problem. So we have our first inequality. We need to isolate the x term, subtract 6 from both sides. 5x is less than -20. Divide both sides by 5. X is less than -4. Our next inequality, we want to subtract 8 from both sides. We get -2x is less than -8. Divide both sides by -2. What happens when you divide by a negative number? Whenever you divide by a negative number, you reverse the direction of the inequality. This is an OR situation. It's a union. X is less than -4 to the left. X is greater than a +4 to the right. So we have both ends of our number line. Interval notation, -∞ to -4, or 4 to +∞. And sometimes instead of or, you'll see a U for union. That's all for this section. Go to the next tape for the next section.